So, good morning, everyone. I hope you all are doing well today. Myself, Kushagra Agarwal, and being a member of renowned club of mechanical engineers, that is American Society of Mechanical Engineers, shortly said as ASME, I am really thrilled to take this session on additive manufacturing. Whether you are new to this world of 3D printing or looking to deepen your understanding, you are in for an exciting exploration. Now, let me give you an overview of today, how we are going to journey, how our journey will look like throughout the session. So, and so a journey will look like see additive manufacturing, giving in highlight of additive manufacturing, that how it is transforming our industries, how it's transforming our real world. So like it's been transformative in a way that how we design, how we create and innovate. In this session, we will cover firstly the fundamentals of 3D printing, explore various 3D printing technologies, and dive deep into the real-world applications that are reshaping industries. Moreover, we are also going to study about various materials used in additive manufacturing and their properties, which is a crucial part of any manufacturing process. Now, thirdly, we are going to go deep into exploring various 3D printing processes like like fuse deposition modeling, selective sintering, selective laser sintering, electron beams, different laser sinterings, and also DLP like the display processing, uh, and unraveling the intricacies of each of these. In lastly, we are going to, and I want to say that lastly, we will be going to study about its real world applications and from business perspective the profit generation from this particular technology in real work and how it is revolutionizing our industries. So giving an overview about what is manufacturing. See, manufacturing क्या होता है? Like manufacturing is the process of converting raw materials. uh, if we study about what is raw material, the starting material of any process in manufacturing, where machining, where the work starts to create any object, to create any shape, something create, कुछ बनाना है, उसके लिए जो सबसे starting material जो रहता है, जिसको अपन लोग like it has been what we can say, it has been metallurgically produced material is used, metallurgically processed material is brought, and it goes through a process of a series of processes under manufacturing. So manufacturing is a process converting raw materials or components, different components being already manufactured, assembling them into finished product. Finished here words means three things. The product being made is tolerable, tolerance is good, dimensionally accurate है, and surface finish अच्छा है. ये तीन चीजें होती हैं, ठीक है? And producing all this, doing all this work on a large scale, ठीक है? Large scale is important work. Mass production we are going to do of it. Involving it's going to involve, it is going to involve design, production, and assembly. Three things. First, design of the product, the blueprint of the product which is going to be manufactured. दूसरा, which is production, which is the actual machining process, where the product will be produced with the use of machines, with the use of tools, and different other helpful different other we can say components. And why we are going to manufacturing, why we are going doing manufacturing, why? Just because, and just why, and why it has so many processes in it. And you can see like here a chart is being made, and see there are about so many processes starting from selection of material, then designing, then production, then logistics, distribution, everything like post processing, distribution, everything like it has been mentioned. So this all comes under manufacturing. People get confused like manufacturing means हाँ कि कोई चीज बनाना है like मशीन पे काम होगा, that is manufacturing. No, that is machining, that is the part of production. But manufacturing, production is not manufacturing, but production is a part of manufacturing process. Okay, so what is our goal? Our goal will be like of meeting customer specifications and demand. We have to meet customer specifications and demand. What is customer want? What does the customer want? What the customer has demanded? Like customer की डिमांड है कि like उसको एक क्या सिलेंड्रिकल कप चाहिए, सिलेंड्रिकल कप चाहिए उसको, ठीक है, एंड उसका शेप ऐसा होना चाहिए, डिजाइन ऐसी होनी चाहिए, एवरीथिंग ही टोल्ड अस, ठीक है। एंड फिर अपना एक अपना रिस्पॉन्सिबिलिटी होती है कि लाइक गोइंग थ्रू व्हाट द कस्टमर हैज demanded and then executing it in all the processes in manufacturing. Okay, so this is a small overview about manufacturing. What is manufacturing? Okay, so what are the different manufacturing processes? I just wanted to discuss what are the different manufacturing processes. So discussing about different manufacturing processes, discussing about different manufacturing processes. So mostly जो traditional processes होते हैं, जो traditional processes होते हैं, वो क्या होते हैं? They are subtractive in nature, where the material is being removed from the part being machining. जिसको मशीन किया जा रहा है वो क्या है, उसमें से मटेरियल को निकाल के कोई चीज बनाई जाती है। वेट अ मिनट। So the first process in manufacturing is the casting process. The different types of manufacturing process. Casting process, where molten material is taken, material is being heated to a temperature which is less than the melting point. It is converted into semi-liquid form and then it is poured into a mold. A mold जो रहता है, it is made of the shape of the object which has to be the object design which was submitted and what is was the requirement of the customer, उस हिसाब से उस मोल्ड को बनाया जाता है। फॉर एग्जाम्पल इफ अपन को किसी कप बनाना है तो कप क्या होता है, अगर अपन को कप बनाना है तो वो जो कप होता है वो कैसा होता है, वो कप जैसा होता है जो डिजाइन होता है उसी शेप का क्या मोल्ड बनाया जाता है एंड देन उसके अंदर इसको फोल्ड किया जाता है, देन इट गोज थ्रू अ सिस्टम एंड देन सिस्टम then solidification takes place and the mold is broken and the part which got solidified inside taken out and that is post processing is done, finishing is done on it, post curing is done on it and then the product is ready. Similarly, but here what is it? Casting. Now machining. Now we can say that what we can say that casting is not a subtractive manufacturing process, it is actually a neutral process, zero because इसमें कोई ना मटेरियल देखो जब ये अपन लोग सॉलिडिफिकेशन हो रहा है तो उसमें ना कोई मटेरियल एक्स्ट्रा आ रहा है ना कोई मटेरियल जा रहा है। ओके, तो दिस इज कास्टिंग। मशीनिंग क्या होता है, मशीनिंग में होता है लाइक द मटेरियल इज रिमूव्ड टू अचीव द डिजायर्ड शेप often with tools like lathes or milling machines. Okay, now machining means like there is a system, there is a what there is a tool machines which are called machine tools like lathe machines, milling machine, these are machine tools on which different machining processes are done to get the required shape, to get the required object we want. how it is done, like for example, knurling is a process, turning is a process, facing is a process, drilling is a process. All these are different processes. Like if we want to we want to make a hole, we are going to use a drill. If we want to make if we want to smoothen the surface of something, we are going to do facing, or turning we are going to do. If we want grooves, we are going to do turning. If you want knurling, if you want grip, diamond shape grip, if then we are going to do knurling, like that. Now, thirdly, there is a forming, like फॉर्मिंग किसी चीज को हथौड़े से पीट पीट कर उसका शेप चेंज करके कुछ और बनाना इज सिंपली फॉर्मिंग. तो मेटल इज शेप विदाउट रिमूविंग एनी, without removal of any material, such as in forging or stamping. Forging होता है, stamping होता है. Joining process. Joining is simply, you all are saying, like welding is there, brazing is there, soldering, the combining materials like from welding, brazing or soldering is joining. Okay, now additive manufacturing. Now there comes the, now what's the thing? See, mostly these traditional manufacturing processes involve subtraction of material. Now, what's the issue with the subtraction of material? See, like subtraction of material is the first most important noticeable issue is that the material is being removed. Material is being removed from the object, from the part which is taken. The raw part is been taken, उससे material को remove किया जा रहा है. Okay, so there is a waste. So there is a wastage of material. So there is a wastage of material. First thing. Second thing is that it requires a secondary part which is tool. And the tool material also get being used, the tool material also gets wasted. And since there is a scarcity of material, the tool which is stronger and compatible in uh, removing material, being with more strength, is are less. So here we have one problem. There are many more problems you can go through and check it on internet and all. More processes are like there is powder metallurgy, injection molding process hota hai. Injection molding is just like casting and all. Extrusion means a material is forced through a die to die casting. Material is forced through a die. See, die to create a continuous profile, often which is used in making pipe or tube बनाने में जो use होता है. So, what is additive manufacturing? So, additive manufacturing, which is also known as 3D printing, is a transformative manufacturing technology. Transformative manufacturing technology, because material has been formed. Technology that creates objects layer by layer. Most important point, layer by layer creation takes place from digital 3D model, CAD model. Computer aided design is being created. We are going to study about it later. Unlike traditional, unlike traditional subtractive manufacturing process that involve cutting away material from a solid block, I discussed this. Additive manufacturing build components layer by layer, offering unique design freedom is being offered and customization possibilities. Okay. Now, what are the points, important points? Like first, how the process additive manufacturing process start. Generic additive manufacturing कैसा होता है? सबसे पहले क्या होता है? एक डिजिटल डिजाइन बनाई जाती है. सबसे पहले क्या होता है? एक डिजिटल डिजाइन बनाई जाती है. द प्रोसेस स्टार्ट्स विद क्रिएटिंग अ डिजिटल 3D मॉडल बनाया जाता है यूजिंग कंप्यूटर एडेड डिजाइन सॉफ्टवेयर. दिस मॉडल सर्व एज अ वर्चुअल ब्लूप्रिंट फॉर द फिजिकल ऑब्जेक्ट. एंड दिस मॉडल क्या होता है? इट सर्व्स एज अ वर्चुअल ब्लूप्रिंट की तरह सर्व करता है. नाउ स्लाइसिंग. व्हाट इज स्लाइसिंग? Second thing takes place is known as slicing. The digital model is sliced into thin cross-sectional layers, typically done with specialized object software. Each layer represents a physical cross-section of the final object. Okay, understood. Now, the each layer represents a physical cross section of the final object. Layer by layer building of object is done by taking smaller components, smaller layers, and then building them. And each layer is a small part of the bigger one, so it has the same dimensions or the same properties as that the whole bigger object. Okay, printing is done. Now the 3D printer, which is the building process. Like here, what is it written? CAD, this is a digital design. Then the conversion takes place into a computer understandable form so that the computer can understand it, feed it, and then send it to the machine, which will, and the machine will perceive this information. The machine will work upon it and start building the object. And the building of the object is done like in 3D technologies, like the building is done by use of 3D printer. So printing is done. We just in which material is being used. Material box is there. Material is filled in it, and the material like different materials होते हैं, like plastics होते हैं. We are going to discuss about the metals, ceramics, and even biological material, bio materials होते हैं. Like okay. Building then the part जो रहता है it is removed from the machine, and then it post processing is done, post curing is done, or we can say where the finish go surface is made more finish of the surface, and then the error application होता है. So this was the basic principle. This was the basic principle of additive manufacturing. Most important thing is layering. Layering in the layer by layer making is done. Layer bonding. The printer. What is the printer? Deposits or fuses the material layer upon layer following the slice design. Now the whole design is being sliced into smaller parts, and smaller parts has hit the individual dimension, and the what does the printer do is data is being fed slice by slice, and each slice is being intercepted perceived from by the machine, and it is then executed. Then it is the digital. Secondly, is the digital design. Okay, this I have the digital model sliced into layer providing instruction for the 3D printer. This point discussed. I've discussed. Mm. What is the significance of additive manufacturing in modern engineering? So, the significance of additive manufacturing in modern engineering. We are going to say these things are like easy. Like what is there? Like the design flexibility is there, complexity we can achieve. Since by complexity we are adding material rather than subtracting everywhere, that's the same reason. Like we are adding material rather than subtracting it, then the it complexity is we can achieve more complexity, and design flexibility can also be achieved. And secondly, iteration can be done, like the data can be documented of the design data can be documented, and then it can be used later on. Now what is customization and personalization? Customizations and personalizations can be done. Okay. Material innovation. Material can be used. Different materials can be used. Since there is no issue of tool, strength of tool being used, since the material is not being subtracted, material is not being removed. So therefore, different material can be used there. That's diversifying the material domain. Automated manufacturing technology evolving to work with various material, including metal, polymer, ceramics, leading to innovative material combinations and property. Lightweight materials can be used. ओके इंजीनियर्स, क्योंकि पहले क्या होता था, अगर लाइट वेट मटीरियल्स अपन यूज करते थे, बट अगर टूल की स्ट्रेंथ ज्यादा भी होती थी, लेकिन लाइट वेट होने की वजह से इट कैन कॉज फटीग टू इट कैन कॉज द ब्रेकेज ऑफ दैट मटीरियल. So that was the issue which has been solved by additive manufacturing. Engineers can design and produce lightweight structure with optimized material distribution, reducing weight while maintaining strength and performance. Okay. Now is the supply chain and manufacturing efficiencies, because the time taking for manufacturing is reduced. Time taken for manufacturing is reduced. time taken for manufacturing is reduced. Therefore, and since the number of processes in manufacturing are reduced, therefore efficiency is increased. Okay. Now, sustainability and waste reduction. This can be understood, and this is most important point. Like material wasted is less since there is not. Everywhere there is the same reason. Then, since the material is not been removed, therefore there is less material wasted. There is no use of external tools. Therefore, energy efficiency is increased and energy is saved. Because, as you know, when the tools works with any part, any on object, there is a contact between both of them, and due to that contact, friction is generated, and the friction causes heat loss of dissipation of heat energy. Okay. Here are some of its industry applications, and there are important applications. Like in aerospace and automotive, designing lightweight components is very important. And complex parts are designed rapid prototyping for test and production. Like for test, if we want a prototype for testing, like something we have to make, we have to test. So rapid prototyping can be done through additive manufacturing, 3D printing processes. And one more thing, like in space rockets, the material where required should be very light, just so that the space rocket, etc., we are sending into the space should should is able to move outside बाहर जा सके. It is able to move outside the gravitational pull of our Earth. Okay. Now I just wanted to discuss different types of additive manufacturing processes. So, seeing into different types of additive manufacturing processes, looking into different types of additive manufacturing processes, I have like there are three major additive manufacturing with selective laser sintering, fused diffusion modeling, or we can say fused filament fabrication, or stereolithography. These are the three important processes. Wait a minute. You can go through what is this fused diffusion modeling. Hmm. So, talking about fused diffusion modeling, what it is. So here, what it is done, the technique involves heating and extruding thermoplastic material through a nozzle layer by layer to layer that is done. Material is being extruded, एक nozzle layer से निकलता है and it is extruded on the platform. Okay, steel lithography, liquid has been used, UV rays are used to, there is, we will study about one reaction that is photopolymerization reaction, it works on that principle, and UV rays are used to initiate that reaction, which causes generation of heat, and the heat causes melting of the material below its melting point, and it will get deposited on the platform which has been built up layer by layer, simple. Now, selective laser, same thing. Laser is being used laser is used to for the heating purpose, such as plastic metals are layer by layer fusing the particles together. Similarly, selective laser melting is done. Similarly, selective laser melting is done. Electron beam melting in which the laser which is being used is specific, which is electron beam, and these are the processes. Now, what are the materials which are used in additive manufacturing? So the materials which are used in additive manufacturing are various across different tech, each offering specific property is suitable for diverse application. Has an overview. Polymers importing materials, polymers like acrylonitrile, butadiene, styrene. What are its properties? It is tough, impact resistant, and versatile. commonly used in fused deposition molding. It is used in FDM just because it is tough and impact resistant. Polylactic acid. Now this is important. Polylactic acid. So polylactic acid, the properties are that it is biodegradable, it is easy to print, environment friendly, it is used in FDM printers. Okay, see, it is interesting. Polylactic acid. Lactic acids are a group of acid which are found in our body, which are degradable. How they are degradable? Because they are found in our body and we are natural human beings, we are natural living beings. Therefore, it is biodegradable. Polyamides are used and polyether ketone, ether ketone. Okay, this is really important. Wait a wait a minute, everyone. Hmm. Hello, everyone. Sorry for the interruption. There were network issue. So we were discussing about the materials which is used in additive manufacturing. So these were the polymers: acrylonitrile butadiene styrene, polylactic acid, polyamides, polyether ketone. Okay. Now talking about the most important crucial uh, materials, which is the metals. First is stainless steel. What are its properties? It is corrosion resistant, strong and durable. Commonly, it is used in DMLS. DMLS is direct metal laser sintering, which is also a type of sintering, and selective laser sintering, and it is a type of laser sintering. Then what is titanium alloy? Titanium properties क्या है? Lightweight है, high strength to weight ratio, biocompatible, and it is widely used in aerospace and medical implant. Important. Aluminum alloy, lightweight है, good strength to weight ratio, corrosion resistant, and it is used in aerospace, automotive and engineering applications. And cobalt chrome alloy है, and high strength है, wear resistance and biocompatibility है, and it is suitable for medical and aerospace components. What are ceramics? Are ceramics like aluminium. It has high hardness, wear resistance, and electrical insulation. यूज किया जाता है and used for electronics, medical and mechanical application. जिरकोनिया की प्रॉपर्टीज क्या है? हाई स्ट्रेंथ है, थर्मल रेजिस्टेंस, बायोकम्पैटिबिलिटी है. बायोकम्पैटिबिलिटी, दिस इज इंपॉर्टेंट. इट इज बायोलॉजिकली compatible, commonly used in dental and medical implants. Zirconia, समझ रहे हो? यूज इन डेंटल एप्लीकेशन, डेंटल टीथ एप्लीकेशन में यूज किया. द composites क्या होते हैं? What are the composites? So composites are like carbon fiber reinforced polymers and glass fiber reinforced polymers. Go through it. Other materials are like wax, which is used in investment casting, sand, which is used in sand-based additive manufacturing, creating molds and codes in metal casting. Now, properties is a very important in material selection. Portable, like for example, if something which has been used, which has to be frequently used in water, should have the property that it is chemical resistant, or working like in nuclear reactors. The covering of the nuclear, like in nuclear plants, the covering of the nuclear reactor should be such that it can absorb the radioactive rays, so that the people which are working outside are not being harmed by those rays. Therefore, they are made of lead. So lead has the property of absorbing these rays. Therefore, material selection is very important for The properties is very important for selection of material in different manufacturing processes. Like one of them, which we are studying here, is additive manufacturing. So, what are the different important properties which are kept in consideration while selecting materials? Are first strength, which is the tensile strength, impact resistance, and fatigue resistance. Durability, resistance to wear, corrosion, and chemical exposure. The temperature resistance, ability to withstand high or low temperature. Flexibility of rigidity, desired level of flexibility or stiffness for a specific application. Biocompatibility, crucial for medical and dental application. Okay, wait a minute. I hope you all are enjoying the session. I I would want to guarantee that you will learn something from here. Something you are going to learn about additive manufacturing in this session, and and it's just the start. We are having two more sessions on it where we are going to explore in depth. We are going to do in-depth discussion about what are the different design processes, how designing is done in 3D printing, and how it is changing, revolutionizing the today's world. We are going to discuss everything, no issues. Now I want to take you a little deep into different 3D printing processes, 3D printing types. Now, so first is selective laser sintering. So selective laser sintering is a powder wet fusion technique which is used in additive manufacturing, commonly known as 3D printing, and it is a process that involves using a high powdered laser. High powdered laser to selectively fuse or sinter powdered material, typically polymers or metal powder layer by layer to create a three-dimensional object. Selective laser sintering is known for its ability to produce complex geometries and functional prototype with good mechanical properties. Okay, so what is the most important point here? Layer by layer, first important, layer by layer deposition of material is done through what it is done laser sintering. Through laser sintering it is done. And secondly, selective laser sintering has the ability to produce complex geometry and functional prototype which can do some function which has good mechanical properties as well. So I want to discuss about the process how it is done. First of all, a powder bed has been prepared in which a thin layer of powder material, which is usually a polymer or metal powder. We studied about different polymers like lactic acid polymer, polyamide polymers, and ether ketone polymers, which was one of the important which I discussed was one of important, and metal powder like stainless steel and all is spread evenly across a build platform. A platform is being built. See here a platform is being built, here it is discussed. Okay, secondly, a laser sintering. A high powdered laser selectively sinters or fuses the powdered material based on the cross-section data derived from a 3D digital model. The laser heats the powder to just below its boiling point, causing now laser sintering is done. High powdered laser is made. See here, there is a mirror, scanning mirror, and laser has been sent, and this laser is a high powered laser due to which heat is generated and the material is being heated just below its melting point, making it semi-liquid, and thus fusion takes place, and then it is made to solidify just to take the shape of what has been feeded inside. Layer by layer building, I discussed. Support structures are required because most of the parts are hanging here. So just to support them, support structures are required. Then lastly, we can say cooling is done. Okay, once a layer is centered, it cools and solidifies before the next layer. Now every layer is made to solidify, cool and solidify before a second layer starts being created. See, I want to discuss advantage also of selective laser sintering. Like it is have material versatility. It is there. Material being used can versatile variety of materials can be used here. Complex geometry, which I already said. No support structures. can be used, but there is no need. Why there is no need? The unsintered powder surrounding the printed object provide auto. And actually the powdered, which is not sintered here, actually provide the support here. Batch production. SLS is now batch production. See, there are three types of production. Okay, there is discrete production, there is a small production scale production, there is batch production, and there is large scale production. Okay, so selective laser sintering जो रहता है, it is used in batch scale production. What are its applications? Prototyping में use होता है, rapid prototyping, customize of products बनाने में, like personalized item, like we can say hearing aids, hearing कुछ अलग अलग वो रहते हैं, orthopedic insoles रहते हैं, low volume manufacturing में use होता है, अपन को पता है, like which is batch production. Now tooling and jigs, creating customized tools वगैरह बनाने, jigs which is a support structures used in tool machining for manufacturing processes, and it is actually widely used in industries like aerospace, automotive, healthcare, and consumer goods for its ability. What is its ability? To produce high quality functional part with a range of materials. What is fuse diffusion modeling? So going through what is fuse diffusion modeling? Sorry, sorry. Fuse diffusion modeling क्या है? So fuse diffusion modeling is a popular additive manufacturing technique which is commonly known as 3D printing. It is a process that uses a thermoplastic filament which is heated to its melting point and then extruded layer by layer to create a three-dimensional. So what is important? Here a thermoplastic filament is used. A thermoplastic filament is used which is heated to its melting point and then extruded layer by layer to create a three-dimensional object. Again, layer by layer extrusion, deposition of material is done, heating is done. See, what is common, I am just addressing it so that you can remember what is common in all the processes and what is the crucial steps in additive manufacturing processes. Okay, so this is done. That it is filament is being used, thermoplastic. Secondly, layer by layer deposition, extrusion is being done, heating is done firstly, then layer by layer extrusion is done to create a three-dimensional object. And what is the principle for it? Laying down principle, simply laying down material in layers. A plastic filament or metal wire is unwound from a coil. Coil चलती है, coil से material निकलता है, like जैसे वो रहता है ना, like we fly a kite and चरखी रहती है, उसके अंदर वो धागा रहता है, it uncoils it and it goes. तो सिमिलरली क्या होता है यहाँ पे, क्या होता है, एक कॉइल रहती है जिसके अंदर मेटल वायर या फिलामेंट जो रहती है, प्लास्टिक फिलामेंट, वो बाउंड रहती है, एंड इट इज अनबाउंड फ्रॉम द कॉइल, द मटेरियल सप्लाइड टू प्रोड्यूस अ पार्ट. Who was a developer of this technology? It was H. Scott Crumb in the late 1980s, but this technology was communicated in 1990. Now, I wanted to discuss about the various fuse deposition modeling processes. So, first, there is a filament loading is done. The process begins with a thermoplastic filament, usually in spool form, which is fed into the 3D printer. Then heating and extrusion is done. The filament passes through a heated nozzle where it melts into a semi-liquid state. The nozzle is moved by a robotic arm or a system of motors, and the melted material is extruded onto the build platform or the previous layer. And then layer by layer building is done. Similarly, support structure is in, cooling, everything is same. I just wanted to discuss, just give you an overview, keeping the session light. What are its advantages? Let me discuss. Material variety. FDM supports a wide range of thermoplastic materials. Remember thermoplastic materials which we discussed, like polylactic acid, acrylonitrile, butadiene, styrene. PETG was polyethylene terephthalate glycol. Terephthalate glycol was there, and many more. Low cost, important, low cost printers are often more affordable as compared to other 3D printing technologies. Ease of use. Printers are relatively easy to set up रहता है. Versatility is always there, variety of materials के लिए. Discussing about like prototyping, applications, prototyping, customization, education में use किया जाता है, educational settings में, toolings में तो use किया जाता है. So therefore I can say fuse deposition modeling may not achieve the same level of details, cannot be achieved, but it is versatile, it is more accessible. And it has popular choice for range of application. Okay, now moving on to next process, that is stereolithography. I discussed about this thing, photopolymerization reaction, in which what wisdom, one of the oldest and widely used additive manufacturing process. In manufacturing process, it is a 3D printing technology that belongs to the category of wet photopolymerization. In SLA, a liquid photopolymer resin selectively cured layer by layer using a laser or other light source to create a solid object. Here, first resin vat is created, liquid resin vat is created. A vat of liquid photopolymer resin is used as a material for the 3D printing process. Secondly, layer by layer solidification is done. Layer by layer solidification means like the selective laser 3D printer is used, stereolithography. The 3D printer begins by exposing. Now the liquid resin which has been spread, which has been made, bat has been made, that is exposed to UV rays. UV rays से इसको expose किया जाता है. The laser scans the cross section of the scanning. This is what I was discussing. 3D scanning. Laser scanning is 3D scanning onto the cross section of the onto the surface of the liquid resin, solidifying it layer by layer. The solidified layer adhere to the previous one. सिंपल, लेयर बाय लेयर मेकिंग इज डन. नाउ प्लेटफॉर्म जो रहता है वो मूवमेंट किया जाता है. ईच लेयर इज सॉलिडिफाइड, द बिल्ड प्लेटफॉर्म इज लोअर्ड and a new layer of liquid resin is spread over the top. The laser then traces the next layer pattern, solidifying it onto the previous layer. Supporting structure, post processing. Once the printing is finished, the object is typically removed from the liquid resin bed. Post processing may involve cleaning the object to remove excess resin, and in some cases additional curing or finishing steps are followed. Now, what are the advantages of stereolithography? High resolution can be achieved. SLA is known for its ability to produce high resolution and high detail parts. Second, smooth surface finish, then wide range of materials and accuracy. What are its applications? Same, prototyping, dental, jewelry, and engineering components to achieve more precise components it is used. So, most important thing is widely used in industry, their precision and high quality surface finish are critical, such as product development, healthcare, and manufacturing. Adding to this, I just wanted to discuss one more process, which is digital light processing. Digital light processing, another which is same as stereolithography, which is another additive manufacturing process in which a digital micro mirror device is used. The 3D printer micro mirror device is used. Then the same UV light source रहता है, layer by layer building, platform movement, post processing. Most advantages क्या है इसके? Like speed, एक की वजह से हाई रेजोल्यूशन होता है, कंसिस्टेंसी होती है, वर्सेटैलिटी रहती है मटेरियल में, कंसिस्टेंसी रहती है, हाई रेजोल्यूशन रहता है. लाइक डीएलपी इज कैपेबल ऑफ प्रोड्यूसिंग हाई रेजोल्यूशन एंड डिटेल प्रिंट सिमिलर टू एसएलए. कंसिस्टेंसी रहती है एंड वर्सेटैलिटी इन मटेरियल रहता है. एंड एप्लीकेशंस क्या रहते हैं? लाइक प्रोटोटाइपिंग, डेंटल, ज्वेलरी, कस्टमाइज्ड प्रोडक्ट्स. I just covered all these part in a speedy manner just because I was wanted to give you a basic overview of the theoretical aspects of this process. Now, I just wanted to discuss some important points. Adding on now, this is done. We have done with the fuse model advantage, low cost, material variety, ease of use, large volume, build volumes for bigger part. Now limitations भी अपन ने डिस्कस कर लिए थे, limitations डिस्कस नहीं कर रहे थे. So फ्यूज डिपोजिशन मॉडलिंग जो रहता है उसके limitations क्या रहते हैं? Limitations रहते हैं like limited resolution compared to some other matter. The resolution is limited. Visual layer lines may require. Now, since the layer by layer building is there, the layer lines which are visible require post processing required रहता है. Now, mechanical properties can be influenced by layer addition. Mechanical properties कैसे इंट्रोड्यूस हो सकती है? Layer addition and orientation से हो सकती है. Wait a minute, guys. Sorry, guys. Just a minute. So we discussed about limitations, advantages. Here limitations are that build size, post scoring is often required. And digital limitations can the size of the light projector, similar post processing requirements and material choices. Lastly, I wanted to discuss. Lastly, I wanted to discuss about some of the real world applications of some of we have discussed some other real world applications of additive manufacturing I want to discuss, and I want to give you an overview about the business perspective related to this technology. So first of all, what is are its application? Most of the application we have discussed, like customized medical implants. Additive manufacturing allows for the creation of customized medical implants which are tailored to individual patients, improving patient outcome and reduce recovery time. Since we know that everyone is different, every body is different, and every body shape is different, like organ shape is different, organ size is different, so therefore there is requirement of variety of shapes, variety of designs. So therefore it allows customized medical implants. Secondly, aerospace innovation. The aerospace industry utilizes 3D printing for lightweight and complex components. This has led to increase the fuel efficiency, reduce cost, and faster prototyping in aircraft and spacecraft production. Automotive advancement, automotive manufacturing leverage additive manufacturing for rapid automatic advancement, customized prosthetics, ISO prosthetics, now toolings and jigs. Okay, these were the and architecture, modeling, construction, consumer goods and fashions, educational applications, different 3D printing valuable educational tool, enable student to bring concepts to life. It fosters creativity, problem solving, and a hand-on understanding of design and engineering print. Supply chain resilience, reduce material waste, and innovation in art and design. And innovation in art and design. So I wanted to just discuss about some of the aspect related to how it is changing business perspective. Additive manufacturing is poised to bring about significant changes in the business landscape. How it is done? First, rapid prototyping and product development. Business can accelerate product development cycle by employing 3D printer for rapid prototyping. Rapid prototyping के लिए अगर अपन लोग 3D printer लें तो our business can be accelerated. Why? Because this allows for quicker iteration, design iteration, and then reducing time to market for new products and reduce time to market for new products. Second is customization and personalization. Additive manufacturing enable businesses to offer highly customized and personalized products to consumers. And this customization is important. This customization extends from consumer goods to medical devices, meeting individual needs and preferences. Third is supply chain optimization. Supply chain optimization में किस तरीके से help करता है? Like 3D printing allows for on-demand and localized production, reducing the need for extensive warehousing and long-distance shipping. This can lead to a more streamlined and efficient supply chain. Fourthly, reduced inventory cost. With on-demand production, businesses can minimize the need for larger inventory. Inventory means where the material is being stored, where the made object is being stored. This shift from mass production to on-demand manufacturing helps in cost reduction, avoid excess stock. Complex geometry and lightweighting. Industry like aerospace and automotive can benefit from the ability to produce complex and lightweight structures. Sixthly, the tooling and manufacturing aid. Business can leverage 3D printing for producing customized tooling, jigs, and fixture, leading to improved efficiency in manufacturing processes, localized production and distributed manufacturing, cost-effective small batch production, innovation in spare parts, improved design iteration, new business models, and sustainability in waste reduction. There are many points which can be discussed, but I am discussing some of them. You can go through and research them on internet and so as businesses embrace additive manufacturing, this tend to gain in terms of agility, customization, and cost. See, cost efficiency is very thing. The profit generation should be maximum if we want to excel in businesses. Therefore, since manufacturing time is reduced, inventory cost is reduced, there is customization, there is more variety of materials available, more flexibility is available, more complexity can be achieved. All these factors cater towards getting a maximum profit, generating maximum profit from a business which requires additive manufacturing processes as a inculcence to it. Okay, so it makes this ability actually help us to rethink about now rethink about in this manner that how this technology which is developed, which is revolutionizing our industries, revolutionizing a day-to-day lifestyle of a person makes is more resilient and adaptive in our business ecosystem as compared to the traditional manufacturing processes. So this was all about for today. Concluding my speech. So I just want to ask you all that how was the session for today? You can drop your you can communicate with us through our email. You can go to asme at the rate nitp dot asme nitp at the rate yeah, email.com. You can go through it. You can go through our NIT Patna website. You can get information more about ASME, American Society of Mechanical Engineers. And I just want to tell you that since we are going towards sustainable development, use of green energy, more use of more ecological sources, uh, ASME standards are working upon it. You can go through them. If anyone is interested joining our ASME, you can take information from the website, from the social media platforms. You can also follow us on Instagram, like ASME and ITP. So concluding our speech, let me go through everything. We studied about the basics of additive manufacturing. We study what is manufacturing firstly, then the basics, what are its application, what are its basic principles, then about different types of additive manufacturing, which is 3D printing types. ठीक है फिर उसके बाद different materials which are used in additive manufacturing, and then lastly we discuss about the real world applications and what is the use of additive manufacturing as compared to traditional, how it is more resilient and adaptive in our ecosystem as compared to traditional manufacturing processes. So thank you for the session, everyone. Thank you for the session, and till for then, bye bye.